Good afternoon. I would like to go over with you how to correct your 420 YouTube homework FRQ. Question 1 was not scored, so disregard any scoring you have on that one. Question 2, it says, graph the results on the axis provided, determine the optimal temperature for the respiration of yeast. So you had to create a graph, and then you had to determine the optimal temperature. All right, we have a couple of really great graphs that were submitted. Here's the first one. So here's the temperature, and this is an awesome y-axis. It says number of gas bubbles produced per minute, which is great. A lot of people have just number of gas bubbles produced without the per minute. That per minute is very important because it could be per year, per second, we don't know. Down here, although they did not get their point because they did not tell me if this was Fahrenheit, Celsius, or whatever temperature magnitude this is. Okay, and we can see this nice arc here at 30, this should be degrees Celsius, so that was our optimal temperature. So for this one, you got a point for correct graph axis. So down here, you got correctly labeled graph, temperature in degrees Celsius, gas bubbles per minute, and then you had to state that the optimal temperature was at about 30 degrees Celsius. Okay, and a lot of you did really well on this. Okay, question number 3, they asked you to create another graph. And this time the graph, instead of making that arc, it says graph this, and then you had to read, it wasn't bolded, it says calculate the rate. And rate is the slope of the line from 0 to 30. Okay, so we have a graph down here, and you should have time in minutes on the x-axis, maltose in micromolarity on this. And then they wanted you to calculate the rate. Now I highly think that this is probably going to be what you're calculating on your AP test that you have coming up. So I think that you guys should be very comfortable with rate. So rate is simply rise over run. So 0 and what was it they wanted? Between 0 and 30 minutes. So rise, we would go delta y, right? So 10, and then run 30, right? So we would take 10.4 minus 0, that's your rise. 30 minus 0, that's your run. Okay, so 10.4 over 30. And then you can reduce that either way. Important part here to get the point, you had to have micromoles up here per minute. That's your rise over your run, and it's a rate. So make sure you have units of both axes on that one. Okay, simple rise over run calculation for a rate. Question 4. Okay, explain why a change in reaction rate was observed after 30 minutes. So they're wanting to know, back for the graph that you did here in question 3, why'd this flat line? Well, I got quite a few answers that said the enzyme ran out of energy, or the substrate ran out of energy. We're not running out of energy here, you're running out of concentration. So as you run out of concentration, there's no more binding sites. There's nothing more to be broken down. So as the concentration runs out, as you're running out of substrate, there's no more substrate left to react, right? So it kind of flatlines. So you got a point for saying that the reaction slowed. The second point was that the enzyme can no longer react to that substrate, right? So that was the last part. All right, then question 5, we have a doozy here. So I had a lot of answer the prompt in your notes. It says, describe a controlled experiment that could have produced the data shown for either temperature or pH. You had to pick one, and you had to show what could have led to this. Be sure to state the hypothesis that was tested. So if you look at the calendar for this day, I told you on the calendar for the 20th, what I was looking for. So I told you right here what you needed to put in that question to get the points. So if we look back over here, I have a really nice response we'll take a look at. It says, an experiment could be held that would yield a graph representing enzyme activity in different temperatures. Good job. So they chose a temperature here instead of pH. Okay. And then it says an enzyme concentration could be given an aqueous solution with a particular substrate. One could choose an enzyme that lets off oxygen particles as a byproduct and measure how long it takes the disc to float. A key thing here that they wanted you to put was that how are you going to measure your results? Okay, so you can't just say I'll measure reaction rate. How? How are you going to measure that? So be specific. Um, and then they gave an independent variable is going to be the varying temperatures. The dependent variable is the enzyme activity, times it takes the disc to float. Okay, then we were looking for constants. What things are we going to keep the same? The size of the test tube, enzyme concentration, substrate concentration, and the type of discs used. Right, then we needed a control, and the control group is the thing that you're not treating. So this could be a test tube with an enzyme that's been denatured, just to see if there's going to be a reaction happening at all in the test tube without the enzyme even being there. Okay, all right, then it asks for a hypothesis. If an enzyme is held at various temperatures, then the further the range of temperatures from around 25 degrees Celsius, the lower the enzyme activity and the longer it will take the disc to float. And they gave a because the enzyme loses optimal function due to denaturing under unsuitable temperatures. Okay? Then we asked for a null hypothesis. If an enzyme is held at various temperatures, then the enzyme activity will not change despite that range of temperatures, and then stated why. This is a 6-point question, and we were looking for these six things in your response to give you all of those points, and they are in the scoring guide. Okay, so please be sure that you are, when you are doing your corrections, looking at the scoring guide to fix your responses. All right, have a great day.